Hi, in this video I'm going to show you how to use just the ANOVA table to solve the problem of hypothesis, okay? Hypothesis test for testing difference among groups. So let's assume you get this table like this and you have to answer the question, do the groups differ in this national computer product? I don't know what this problem is. Let me see if I have somewhere. No, I don't have the problem here, but anyway. Let's assume it's a problem and we have three groups, national computer products, and we want to test if the groups vary in these national computer products, okay? And you get this table. So let me show you how to go about this problem. So the first step is always come up with the null and alternative hypothesis. Let's assume we have three groups and then we want to test if the groups differ or they have the same mean. For whatever the mean is. I don't know what the mean is in this case, but it's just an it's just a hypothetical case. And the null hypothesis that the means are equal, the alternative hypothesis that the means are different. Okay, all right, now what you have to do is fill out this table. And let me copy this table very quickly while I have it here. Source of variation. No, it's not good. Let me do it again. So let me see. Okay, so what I did is I simply have the same table from here to help show you. So the first piece of information I have is 516, second piece is 846, and here is 2, and here is 15. Okay, so this is what I have. Okay, so how do I go to solve this problem? Well, my objective is to find the F statistic and the p-value, the probability value. So I have to fill out all this table to get to that point. So the first thing I have to do is how much is my sum. This is the source of variation. My sum of square error. Sum of square error. How much is this? So the total here, this total is the sum of this number 516 and this number in the middle. This sums up to 846. So let me write that for you. So the sum of square total is equal to the sum of square treatment plus the sum of square error. So if my sum of square total is 846 and my sum of square treatment is 516, how much is my SSE? So what I have to do is I move this number to here and subtract from 846. So if I subtract these two numbers, let me show you in Excel. So my SSE in this case is going to be equal 846 minus 516 is 330. Okay, I got that. 330. My degrees of freedom here is 2. Remember this. So to help remind you, I have here, this is k minus 1. So k minus 1 is equal to 2. If I move this number to here, I have k is equal to 3. I have 3 groups. Because I know that I have 3 groups because k in this case is 3, right? 3 minus 1 equal 2. And here, here I know that this is n total minus k. So nt minus k groups groups is 3 is equal to 15. I know that the total sample size will be equal to 15 plus 3. Total sample size is 18. So if I have 3 groups, I have 6 observations in each group, right? 6 obs in each group. Okay, now that I know all these pieces, I can divide this number by this number. And if I divide 516 by 2, I get the mean square. So if you don't remember, you can look here. Sum of square divided by k minus 1, and you got that. Okay, so 516 divided by 2, let me take a look. Let me put here, mean square treatment is equal 516 divided by 2, 258. So this number is, now I'm gonna do 330 divided by 15. So the mean square is equal 330 divided by 15. 15 is 22. Now if I divide, I'm going to divide this number by this number and I get the f, okay? And again, you can take a look here. The f is this number divided by this number. So 258 divided by 22, I have my f statistic. So my f stats is equal to this number divided by this number, which is 1172. So it's 1172. All right, now I have to find the p-value of this number and compare with the alpha level. Let's do this. So p-value is equal to f dot dist dot rt, open parentheses, and then I have to select this f, comma, degrees of freedom 1, I go back, degrees of freedom 1 is 2, comma, degrees of freedom 2 is 15, close parentheses, and the f is very, very small, much smaller than the alpha level. So this is, I'm not going to write here because it's too small. Let's put it here. 0.0008, I think. Yeah. So reject the null. Why I reject the null? Because the p-value is smaller than the alpha level of 0.05. Okay. Well, let's go back to slides and see what the slides have. Did I do something wrong here? 530. Nope, that's correct. I think that my slides have this typo here. I have to correct. Let's do it now. Okay, so this is 22, and the f is 11.72. Okay, so that was a typo in my slides. But anyway, this is the same thing we found, and then you get the p-value, and that's it. Let's take a look at a different example. Let me show a different example that you might get from the book. Okay, so the book is closed. Let me open the book again. So this is chapter 13, analysis of variance. Let me see if it is in here. I don't remember. Now this is all raw data. Some of them are not raw data, but let me see if I can find. I don't have here any problem. Let me see if they're here. Otherwise, I can open the homework to show you. No, let me open the homework to show you. You see, that's the same problem. We have sum of squares, we have the total, and then you have more information here. For example, in a completely randomized design, 7 experimental units, 7 people, were used for each of the 5 levels of the factor. So how many groups we have? We have 5 groups. Okay, 7 people in each one of the groups. So how much is the sample size? So let me just show you how to work on this one. I don't want to solve it, but I want to be able to. So that's a piece of information you need. How many groups? How many groups we have? We have 7 groups. Groups equal to 7. This is equal to our K that we're gonna need to use. How many people? People, each group. Oh, I'm sorry. I'm so sorry. That's 5, not 7. People in each group is 7. Each 7. So what is total sample size? Total sample size is equal to 35. So this is my NT. You're gonna need that for the degrees of freedom, okay? So you have to be able to read the problem and understand what the problem is talking about. So using these pieces of information here that I just showed you, you can get the degrees of freedom. You can get this sum of square error, and then you can solve everything, okay? So this is what I was trying to show you. Let me see if there is another one. No, this is like doing as one of the first problems I did with you, like you have the raw data and you have to come up with the solution here. Let me see. This is another one. Okay, this is the same one. Okay. Let me see if there's another one. No. See if there's another one here. Oh, you see, this one is totally empty, but you have you have pieces of information here that helps you to fill out this table. So this is what you have to practice. This is the kind of problem you're gonna have. Okay. So again, use this table to help you fill out. You have to understand how to fill out this table. I just showed you how to complete this table here from scratch. Sometimes you have different kinds of problems. Sometimes you have the mean square and you have some information here and you have to fill out the table. Okay, but this, you have to understand the relationship among these numbers in the table to be able to complete it, regardless of the piece of information you get. Okay, that's it for this problem.